All right, hi everybody. In this lab you're going to explore conservation of energy by analyzing a pendulum. So what's a pendulum? Okay, a pendulum is really nothing more than a mass that hangs from a string. This is a useful trick when you're trying to hang a picture straight in college and you don't happen to have a level. Okay, we know gravity only pulls straight down, so what we have here is a perfectly vertical line. If we set the pendulum or the plumb bob into oscillation, well, now it becomes a pendulum. All right, in the lab, you're going to make some predictions and observations. You also need to make some measurements. All right, the lab is divided up into two sections. There's two pendulums set up, one that has this brass mass, and the other that has this number 3 fishing weight. This will be the cut short pendulum, okay, because the lab is divided into two parts. So when you make your measurements, all right, you want your measurements to be to the center of mass of the pendulum. That's its balance point. The pendulums have these number 3s stamped on there, so that's approximately where the center of mass is for your pendulum, but you want to check to be sure. So what you want to do is when you get out to the lab table, is just try to take the pendulum and balance it on your finger, and that's its balance point. That's its center of mass, and for me it's pretty much right at the top of the number 3. That's the way I'm going to make my measurements. Okay, the next thing that you need to do is you need to pick a start height for your pendulum. Okay, and you're going to want to record this value. The numerical value isn't so important as long as you stay consistent. All right, you don't want to release the pendulum from too high, okay, to where it's falling and the string comes loose before it starts swinging, and you don't want to go too low either. So somewhere a nice middle angle is good. You're going to make your measurements relative to the table height. Okay, so pick a nice round number. Okay, so I picked here, and you know what? I think I'm going to put that here because it puts it right at 60 centimeters. Okay, and for every trial for the cut short, this is where you want to release from. So once you pick this, you want to stick with this, okay? You're going to be making some predictions about releasing the pendulum and making predictions about where it's going to swing. So the pendulum is going to swing down through its path, and then it's going to swing over here. Now, your predictions are going to be based upon observation. And when you release the pendulum, you want to know, is it going to swing lower than the height that you release it, equal to, or above, okay? And so you're going to want to test this several times and come to a consensus with your teams before you make a decision, all right? Once that's done, you're going to introduce this second crossbar so that when you release your pendulum from your start height, and again, that needs to be the same every time, okay, that the swing path of the pendulum is literally cut short by this crossbar. All right? The first thing you're going to do is set your crossbar equal to the height to which you release the pendulum, which for me was about 60 centimeters. Okay? And that's the height from which you're going to release your pendulum. And again, it's about making predictions and then making observations. So when the pendulum hits the crossbar, our options are swinging to somewhere lower than the crossbar, swinging equal to the height of the crossbar, or swinging higher than the height of the crossbar. Okay, and of course we know that we're in lab, so we expect some error. So when we're talking about equal to the height of the crossbar, anywhere in here, we call it about equal to. If it's either lower than the crossbar or higher than the crossbar, it will be obvious to you. Okay, and then you're going to move this pendulum, or you're going to move this crossbar up and down, and you're going to repeat prediction, observation. Okay. Later in the lab, all right, you're going to find the point to where you can lower this crossbar to where your pendulum is going to loop around it. So, like, you're going to find that spot there. All right. The lab asks you to measure the height of the loop. And what that means is when the pendulum comes in and comes around, at its highest point, which would be the very top of its loop, how high is it above the table? And again, we want to measure to the center of mass. So you would make your measurement here, and for me it's somewhere around 55, 56 centimeters, okay? And you're going to compare that to the drop height, all right? And from there you'll be able to do some analysis in terms of conservation of energy. That completes the first portion of this pre-lab. We'll pick it up over on the other side of the table with conservation of energy. Okay, everybody. The brass mass and the photo gate here is what you're going to use for the second part of the lab, which is the conserving your energy. I just want to note that we have reversed the lab setup. You'll just move to the other side of the lab table rather than take the whole setup down and set it up. Okay, so in the cut short part of the lab, you look at conservation of energy qualitatively. Well, here's where we want to prove conservation of energy quantitatively. All right, what you're going to do is determine the amount of potential energy that a raised pendulum has. All right, and you're going to release it from rest, or when it has no kinetic energy. And the hope is that whatever potential energy the pendulum has here will all be converted to kinetic energy at the lowest point in the swing. And that's the point where the pendulum is going to swing through the photo gate. All right? The thing that you have to be careful of, all right, is the lab asks you to choose a start height, all right, to release your pendulum. In fact, you'll pick 3 different start heights, all right. So here's what can throw you off, all right. This pendulum is a cylinder, okay, so using its geometric center, which is about here as its center of mass, so just like with cut short, that's where you want to make your measurements from. Okay, well, let's say I want to choose 40 centimeters and release it from 40 centimeters. All right, well, if I let the pendulum swing down, it's not going to lose a height of 40 centimeters because the pendulum doesn't hit the table. It swings to some low point that's above the table. The lab calls this the HAT, the height above the table. So you'll want to measure this. Okay, and for my pendulum, it's roughly 15 centimeters, all right? You're going to want to make a measurement that's a little bit more precise than that. All right, but let's say I want the pendulum to fall 20 centimeters from where I release it. Well, then I need to have my drop height 15 centimeters plus 20 more. So I go up to 25, 35, and then 40. If I did that, let's see, this 10, 20, well, that'd be 25. I made a mistake, I'm sorry. It'd be 35 centimeters, okay? So, to fall that 20 centimeters, I'm actually going to release it from a height of 35, and it's going to drop down to a height of 15. All right, in my data table, all right, the actual drop height is going to be that 20 centimeters. Now, the photogate is a fragile data collection device, okay, so what we want to try to do is avoid having the pendulum run into it as much as possible. So when you release your pendulum, all right, you're going to want to have a lab partner on the other side so that the pendulum only has to swing through it one time. All right, so Mr. Gierman is going to help me out, and here we go, 3, 2, 1. And that's how you're going to do your testing. So in the conservation of energy lab, what we're trying to do is prove that when the pendulum swings through the photogate, its kinetic energy will be equal to the potential energy that which we released it from. Okay, so how is it that we're going to determine the kinetic energy of the pendulum? Well, what the photogate does is the photogate uses an infrared light. There's two sensors, or there's an emitter and a detector. Okay, here's the light, excuse me, and here's the sensor. What the photogate does is all it does is record time values. So when you start the photogate, that's arbitrary. It's not going to give you any data until it's blocked. All right. So what you're going to do in the lab is by allowing the photogate to swing, or the pendulum to swing through the photogate, you're going to get 2 times. The first time that will be recorded on the computer screen will be when the photogate is blocked, and then the second time will be when the photogate can see the detector again. And it's going to be the difference of those 2 numbers that's going to allow you to calculate how long the pendulum swings through the photogate. And when you do this, you're going to get some very small numbers. All right, the pendulum has a fixed diameter. It's not going to get any bigger or any smaller. It's 2.8 centimeters. So what we have here is a known distance that moves through a point in space in a time that you're going to measure. If we have a known distance and a calculated time, that's how you're going to record velocity, and the mass is printed right on the top of the pendulum.